Hi, this is Bharat Durguju. Today I'm going to explain the solution for the long short-term memory. So, as by my understanding, so for the assignment 5, we are using the long short-term memory as a LSTM, as we predict the number of passengers in an airline for the next day, and as per the given, these are given, and the number of passengers of today we're going to predict. So here we are importing the necessary libraries for this code. We are importing math and num as a plotting function. So here we are using a pandas as PD. So as a plotting function, we have taken a matplot library.pyplot function, and from the sklearn pre-processing, from the sklearn we are imported minimum maximum scalar and mean square error, and import the train test split. So from the TensorFlow, we gonna import the keras, and from the keras model, we gonna import sequential. We have import the dense and LSTM from the keras layers. So for this, the first, so the f- for these things will we which we have imported from the auxiliary libraries, and these we have imported from the keras and relevant functions. For this, we're gonna download the data which we provided in a GitHub, so which our professor shared. So as we have a link which was a data for the airlines passengers. So here we have assigned for the read. So first we read the link which was given by the airlines passengers data. So we gonna assign for the airlines, and we gonna print the given data set of the airlines as a heading. So here we assign a 40 for the subset size, and we're gonna assign airlines months and syntax for the airlines as month, and 0 is to subset 0, which we have taken the 40 for here, and this line will be assigned for the subset months. And for the passengers, we gonna assign as subset underscore passengers. We are assigning the airlines of maximum passengers and minimum passengers. The passengers is to 0 is to subset of size. As for the plotting function, we have assigned a plotting size of 14 is to 14, and 80 is a dotted per inch as a figure, which we have seen later after coding. And for the range, we have taken uh, a axplot auxiliary dot plot and range. We have taken the length here and the numpy as array as a subset for the passengers, and we assign a place for the as a addition. So label is equal to, we are giving the visualization of the label name as a passenger count. As an auxiliary plotting function, we assign alpha for the same line. The alpha will be 0.5. As auxiliary set, we gonna range will be length of subset of months. So, and we here providing the hash, and the column prevents the display for the auxiliary output. So after, and here we are but the mandatory will be plotting x ticks. So for the rotation 45, we gonna exactly the points will be shown here when we ticks as per the graph goes. So here we using a legend function here. So as a code, as this given data will be a raw data set. So as I've already said here, I've explained about the code, and the output will be the size will be. So for this size, we're gonna open uh, uh, so as we have got a local temporary, the data of which we provided. So here the airlines will be the GitHub, which I have talked, we have already said. As this is a code, this is the output we got. So, and here, so yeah, this is uh, yeah. This for this code we got a packages of we got a link for this wrapper as .args and .kwargs. For here we for this we got a stack level is equal to stack level. After returning this function of so and so this function of args and kwargs, um, we get a packages and we read all these packages. Here we are getting so and so error for error tokening data and see error expected one file in 2027. So this code we're gonna come airlines is equal to PD read. So here we also using the data which we are providing for the passengers. Here the comment will be airlines.head comment. So we are assigning the airlines passengers to the passengers and printing the passengers. Uh, here, after loading the data set for the visualization, we're gonna use a subset of the data set and we're gonna download the full data set which we present in the GitHub. And after downloading the provided data set, we're gonna assign as a read option, and we're gonna assign to the airlines. For this we for viewing we're gonna for view the full data set, we're gonna print the data set as a which we have assigned for the airlines.head function comment. We're gonna print that, and previously we have taken the subset for size is 40, and the subset month we have already taken before as the same we are writing the code for this. And the data sets and the output of the data set we got is during duration of 1949 to 1901 we got 112 passengers. During this duration we got 18, and these are the duration months, and for these are the passengers list how which we are how many passengers we have traveled. So uh, for the as a plotting we are using legend function. So here we got a dotted where we have plotted a as a plotted we have got some dots in the graph. As per the dots we have marked the lines for the representation of the given graph. How many passengers has increased from 1949 to 1952. So here the graph shows somewhat as we have a inclined and decline curves here. So from the starting to the last, as per the graph has been increased. So after that, we're gonna working with the passengers column to use the code. We're gonna process the data for the passengers column and take a look into it, the convert its type and reshape it and print its size and the minimum and maximum values. For this, we're gonna use the passengers data as we have assigned the airlines passengers to the passengers and printing the passengers list. And the values the passengers details we're gonna shows as a num arrow of the data type which is float which will be a decimal values. So the data we gonna assign the passengers dot value of floating data type. The reshape of size is -1 to 1. We gonna assign to the data set, and printing the normalization form as we have given this data set shape is equal to shape, and the maximum will be data set max, and the minimum will be minimum data set. So for the passengers column list, we have 112, 118 as we got earlier. The passengers name will be displayed here, and which type are they are they men or female or something. Before the normalization we given the shape is equal to data set of a shape, and we have given 144 shape. So we have given 100 and shape is equal to 144 and 1. The max will be 62 and the minimum will be 104. So this is the output for the code. Let's and next we're gonna normalize the data and the data set variable using a minimum and maximum scalar, as we're gonna initiate the maximum and minimum scalar function object, and we're gonna use the fit transformation function for the scaling data set, and we're gonna print the data set and for the minimum maximum values. So we are getting a minimum and maximum values after the normalization. So as I've already gotten the output, we got a shape of 144 and 1. We're gonna take this as a data 1, data 0, data 1, data 2, data 3, and so on for the 143 till 143. So for the normalization data, we're gonna assign minimum and maximum scalar of with the function range of will be 0 to 1 will be assigned for the scalar, and the scalar for the fit transformation of data set will be assigned for the data set, and printing all these data, the shape and maximum and minimum values, we get a normal after normalization we have got the same, as the shape will be 144 and 1, and the maximum value of the code will be 1. So and the minimum will be 0. So after reshaping the data set of 144, as a result we are getting and we also made the data look like data 1, data 2, as we have taken the separate in the before. So we are combined, right, we have taken in the bulk set. So before we have divided the data and we gonna normalize the data. So here as a result we gonna add all the data in a set. So and we gonna uh, do the code for this. So for this we gonna reshape it and will be assigned for the data set, and we print the data set. So here we getting 144 only. So these are only 143, as 0 is included, so we got 144. For this we gonna predict. So for this we have done a prediction for this problem. So here the passengers number of day will be 0 from right today, and to the product and two we predict the passengers for the day 1, like tomorrow. We're gonna predict today and tomorrow how much, what is the difference between 0 and 1. So how many passengers are and the input features we have. So for the output label, we're gonna convert the single sequence of data which we have which we have the uh, visualization, which was the picture shown here. We're gonna convert the single sequence of data into label example. So this is a sequential data. This will be the data point of 0 and input feature X, and the label Y of the data point 0 will be uh, assigned for the sequential. So and this will be assigned for the data point 1, or all are included for the all are connected for each other. So here we are using uh, defining a data set as a D set and look back. So here we are taking look back is equal to 1. So here the label will be we are taking a 1. So and we are leaving the X and as an empty and Y as an empty. For here we are using a loop function. So for I is equal to range of length of data set is equal to look back is equal to 1 minus 1, sorry. The label value, we are assigning the data set of I plus look back as the output label, and the X value, here we are using I plus look back. So here we are using a ratio for the input features. For the labeling, we are using y dot append of y value and x dot append as a x value. So and after that we gonna get the return value from y label and feature. So and the look, as we have already function use a function which we have taken, and we for the 0 for the and from the today and from the tomorrow we're gonna take these duration for so the look back will be 1 and the data x of the data y will be the data set of the data set of look back and data set will be printed. So here we are getting a 142 1 and 142. So after this is an output. So here for our understanding we're gonna split the data into data x and data y. So here the feature and the label will be divided into training set and test sets into the 7.3 ratio as it is, and the training set will be 70% and the test set will be 30%, and after that we're going to shuffle to the true and the random state for 242. So this is an experiment. So store the values in an X train and Y train as this is a feature. So as a label train and as label train Y train and Y test. So and we reshaping all these uh, test sets. So for this we're gonna take the test size is equal to 0.3 and the shuffle will be true and the random state will be 42, and we're gonna divide the data into 70 to 30 from all data test set and training set and printing the values. So we are getting the train shape will be 99 and 1 for the features and the label will be 99. The test shape will be, so we are getting a features as 43 and 1 and the label will be 43. As we got before, we got the training set and the test set value according to the before code. So after this, we're gonna build LSTM, the long short term model with the two layers. The first layer will be 100 with 100 units, and the input shape is will be 1, and the look back value is 1. So we have already taken before, and the second layer will be a dense which we have imported with from the library with 1 unit. So after compiling this code, and we're gonna train the model for compiling, and we're gonna set the loss and the mean squared error and the optimizer to Adam. So for this training set, we're gonna use EPCOS to 10 and batch size is 1 and verbose to 2. So here for this data, we're gonna use some references from the Longshot, LSTM, and dense and the compile and fit. So and we're gonna build a model train. Here we are assigning the sequential function to the LSTM, and here we are using the add and LSTM input shape of 1, the size 1, and we are taken the look back of 1, and we have given a summary for the LSTM and compile it and print it. We're gonna get a size limit and the text editor form. So for the LSTM, the output of shape will be 0 to 100, which 0 is not included, which is none. So we got a parameters of 40,800. So for this dense we got none and 1, which is the output shape, and we got a 101 parameters. The total parameters are 40,901. The training parameters as equal to our predicted value. So here for the EPCOS we got 100 of 10, we got no loss for the 4-second EPCOS. As until we have done 1 by 10 to 10 by 10, we got no loss. We have got the loss is reduced as we are increasing the size of the data. And for the model uh, for this data set, we gonna train it as a test set for error. So here we are using the test model for making a prediction. We have taken the training set and the test set as a prediction. We're gonna assign the predictor X train and Y train and assign for the predictor value, and convert the prediction value for the original range. So here we're using the scalar and inverse for transformation, and we're gonna assign the training the label. We're gonna We're gonna assign for the label, train set, and test set, the scalar and inputs for transformation, and we're gonna print the prediction train set and test set, and compute the RMSC and print the value. So here the training set of RMSE will be 34 and the decimal value, and the test for the test set we RMSE will be 33. So let's compare some prediction against the actual labels. So for this code we got a visualization for according to the code. As for this code, we're gonna see the plotting which we have done. Before we have taken the plot size, sorry, we have taken the x plot size as 30, and we have taken the prediction size -1 of the plotting size is which have 0 and is to plotting x size. So for the x size, for the x axis, x underscore axis, we have taken the range of x size plot. So for the range we have taken from the plotting, which we have taken the size from the x. So for this we for the figure we have taken the a plotting function here, and the figure size will be 12 and 14, and the dot of DPA will be exactly 80, and we have done the predictions for the alpha 0.5, and the label will be predictions as per the x-axis and y-axis. So here we have two labels, so prediction and the ground nuts, sorry, ground truths, sorry. uh, as we have taken the xtix label, x labels and y labels and title, as we have taken the model performance on subset of type set. So here we are using a legend function and the plotting as plotting to show to view the plotting. So for the plotting we gonna assign as prediction of training set, and the label train as train, and the plotting of prediction test and y test. For this one here we have already seen the x mark. We have seen the ground truths, and the dotted red line dotted will be a predictions which we have predicted. And after the code, visualizing the code, and after compiling, we get we have changed the image which we after getting the normalization. We have already seen the given the output which we normalized before and the after, so we have changed that. uh, yes, this is my understanding of the solution. Thank you.